All right, welcome to The Explainer. Today, we are cracking a 4.5 billion-year-old cold case, and it's a big one. The violent, mysterious birth of our very own moon.
I mean, think about it. We've been looking up at that thing for all of human history, right? But the question, where did it actually come from, has been a real scientific puzzle. And it turns out, the answer, the story behind those peaceful moonlit nights, well, it starts with total unimaginable chaos. And you know, like any good detective story, it's always that one clue, the one little piece of evidence that just doesn't quite fit that ends up breaking the whole case wide open. So that's what we're going to do. We're going to follow the clues all the way from the early solar system right down to the labs here on Earth. Okay, so to really understand what happened, we've got to go back to the scene of the crime. Let's wind the clock way, way back. I'm talking 4.5 billion years ago. So, you gotta picture this. The early solar system was nothing like the orderly place we see today. It was a complete mess. A cosmic shooting gallery, a demolition derby of giant half-formed planets and asteroids just smashing into each other. And our brand new young proto-Earth, it was right in the middle of all of it, on a collision course with destiny. So, for decades, there's been one prime suspect in this cosmic crime. It's a theory with a name that sounds just as epic as the event itself: the giant impact hypothesis. The basic idea goes something like this. About 4.5 billion years ago, our young Earth got absolutely walloped. It wasn't a head-on collision, more of a massive glancing blow from another protoplanet. And this impact was so powerful, it literally reshaped our entire world and just blasted a huge cloud of debris into orbit. And this planetary body, this impactor, it's got a name: Theia. They named it after the Greek Titan who was the mother of Selene, the goddess of the moon. Pretty fitting, right? Now, Theia wasn't some little asteroid. This thing was a monster, about the size of Mars and packing around 10% of Earth's mass. Okay, so it's a great story, right? A cosmic crash. But where's the proof? How do we know any of this actually happened? Well, it turns out the evidence was just sitting there, waiting for us, on the moon, locked away inside its ancient rocks. This is where the Apollo missions come in. Between 1969 and 1972, those astronauts basically became cosmic detectives. They brought back 842 pounds of moon rocks in soil. I mean, that's our forensic evidence. And it completely changed everything we thought we knew about the Earth-Moon system. So, what did this evidence tell us? Well, it painted a really dramatic picture. The rocks showed that the moon was once just a molten ball of magma, which points to a birth of incredible, unimaginable heat. They also revealed it has this tiny little iron core, and it's missing a lot of what scientists call volatile elements, stuff like water and zinc that vaporizes really easily. All of this was screaming, I was formed from lighter stuff that got blasted off in a super high-energy collision. But it was that final clue, the chemical fingerprint, that turned into a massive puzzle. And this really gets to the heart of why this is so cool. We're not just figuring out where the moon came from, we're actually learning about our own planet's story. Their histories are totally, completely intertwined. But that very connection, that link, was about to cause a huge problem for the whole giant impact theory. You see, for all the things the giant impact theory got right, there was this one big, glaring problem. A loose thread that, for decades, threatened to unravel the entire case. Okay, here's the problem. Think about it like this. Every planet in our solar system is made from a slightly different recipe of elements. This gives each one a unique chemical fingerprint, or what scientists call an isotopic signature. So if the moon was mostly made from the wreckage of Theia, it should have Theia's fingerprint, right? But it doesn't. It has Earth's. It's an almost perfect match. Yeah, the early computer models of this collision, they all suggested that the debris that eventually formed the moon should have been like 70% Theia, so everyone expected the moon to have a totally different chemical signature. But when they analyzed those Apollo rocks, nope, it was a near-perfect chemical twin to Earth's own mantle. This was a huge contradiction. I mean, how could the moon be the result of a collision with Theia, but have almost zero trace of Theia in its DNA? It's like finding the getaway car, but there's not a single fingerprint from the suspect anywhere inside. For years, this isotopic puzzle had scientists totally stumped. And then, a breakthrough.
Thanks to some seriously powerful supercomputers, scientists were able to rerun the simulations of the impact, but this time at a ridiculously high resolution. And the result? It was absolutely stunning. It changed everything.
See, the old models, they showed this long, drawn-out process. A disk of debris forms around Earth, and then over months, maybe even years, it all slowly, gradually clumps together to become the moon. But these new, super high-res simulations, they showed something totally different, something way, way faster. We're not talking millennia. We're not even talking years. The new models showed that the moon could have literally formed in a matter of a few hours. And this one change, this incredible speed, it provided this beautiful, clean, elegant solution to the whole mystery. Okay, so here's how this new single-stage theory works. Instead of just a glancing blow, it was a more direct, much higher energy impact. This thing absolutely vaporized chunks of both Earth's outer layers and Theia, blasting this mixed-up material directly into a high, stable orbit. And then, almost instantly, a huge clump, our proto-moon, formed right out of that cloud of debris. And here's the magic trick. Because so much of that debris cloud came from Earth's mantle, it perfectly explains why their chemical fingerprints are identical. The case of the cosmic twins was finally solved. What's even cooler is that this also explains other weird things, like why the moon's orbit is tilted.
So when you look at the whole story, this violent history isn't just some fun cosmic trivia about the moon. It actually tells us something really fundamental about how rocky, habitable planets like our own are even made. It turns out these giant, world-shattering impacts might be a key part of the recipe for creating a world that can eventually harbor life. But you know what? The story isn't over. Not by a long shot. The upcoming Artemis missions are going to send astronauts back to the moon, and they're going to bring back new samples from totally new places, maybe even from deep beneath the surface. And that new evidence, it's going to help us confirm this incredible new story and, no doubt, unlock even more secrets about the shared history of the Earth, our moon, and ultimately, of us.